intro for today, and today I'm going to be showing you guys about substitution. This is actually the second day of substitution. It's one of those bigger topics that's important to spend a little time on. So we're going to do some more problems. First one I would like to show you is this one. Just going to jump right in, start doing problems. Number one is x minus y equals -1, and the other one is 6x plus 2y equals 10. Okay, so the first thing I need to do is I got to get x alone or y alone if I'm going to substitute that in, which means I'm going to take that top equation and work on isolating one of those, because it's going to be much easier than the bottom one probably, because I won't have to divide by 6 or I won't have to divide by 2 at the end, since those have those coefficients. So if I take this equation, and let's just say I add y to both sides, that'll get me x alone, -1 plus y. Alright, so that's what y equals, or x equals rather. So I can take that now and I can plug it in here into the x in the other equation. So like what I've told you before, I like to do is I like to take the equation where the variable I'm substituting in for, and put big blank parentheses, but everything else stays the same. And in the parentheses goes what I'm plugging in, which in this case I'm substituting in -1 plus y. So that goes in for the x. And now I take a look at my equation. I have just one variable, which is good. Now I can solve this out and I'll get my first answer. 6 times -1 is -6. 6 times y is 6y. Now I can combine like terms. 6y plus 2y is 8y. And then I can add 6 to both sides. I get 16. Whoops, a little ahead of myself. 8y equals 16. Divide by 8. Y equals 2. And that's my first answer. Remember, I'm not done. I need to find what the other answer is. So take either of the equations, pick the easier one. In this case, I am going for the x minus y equals -1. And I'm going to plug the 2 in there for the y. So I got x minus 2 equals -1. And then I can solve it. Add 2 to both sides. And I get x equals 1. I'm going to check it. Check it in at least one equation. I'm going to check it in that 6x. You should check it in both equations. 6x plus 2y equals 10. These are my two answers. I can circle them. So when I plug those in, I get 6 times 1 plus 2, y is 2, equals 10. 6 plus 4 equals 10. 6 plus 4 is 10. I'm good. You can check the other one. X minus y equals -1. X is 1. And y is 2. 1 minus 2 is -1. -1 equals -1. Good. So that's how you check them. All right. If you have questions on that, please bring them to class. Number 2. Y equals 2x plus 1. And the other one is y plus x equals 4. Alright, so the first thing I do is I look to see if I have x alone or y alone in either equation. Right here I have y equals, that's beautiful. I can take that and just plug it right in there for y, which gives me 2x plus 1. You can use parentheses, but in this case you actually don't have to because there's no coefficient. So you could put it there, but then you're just going to drop them. When it's crucial to have parentheses around it is if there's ever a coefficient, if there's a 3 on that y, or if there's a 2, or any number other than 1 in front of the variable you're substituting in for, you got to make sure you use parentheses. Alright, so anyway, I'm going to drop these. And now I can solve this. 2x plus 1x, that's 3x plus 1 equals 4. Subtract 1 from both sides, I get 3x equals 3. Divide by 3. X equals 1. There's my first answer. Now I got to find my second one. I got to find out what y is. Pick either equation. They're both pretty similar. I'm going to take the top one of y equals 2x plus 1 and plug in 1 for x and get y equals 2 plus 1, which is 3. And that's my answer. Okay, you should go check your answers. In the interest of time, I'm probably not going to check every single one in this video. I've already done out the problems. I know what the answers are, but you certainly should be doing that, especially on quizzes or tests. All right, number 3. I got 5 problems for you guys today. Number 3 is x equals negative 2y plus 4. And the second equation is 3.5x plus 7y equals 14. Okay, do I have x equals or y equals? Yes, I do. In the first equation, I have x equals. So I'm going to take that and I'm going to plug it in for x. So that goes with the parentheses. I know that's a decimal. It looks kind of ugly, but it's actually just 0.5, which means it might not be bad at all, especially since I see some even numbers coming in here for the substitution. Okay, so take a calculator if you like, but when you multiply 3, I'm going to do distributive property, 3.5 times negative 2. That's going to be a negative number. 3.5 times 2 is 7. 3.5 times 4 will be 14. Plus 7y equals 14. Ooh, interesting thing happens. I'm canceling all my variables out, and I'm left with 14 equals 14. Oh, we haven't come across that before. This is one of those special cases, which means since I got 2 numbers that equal each other, this is going to be infinite solutions. Okay, if I got 2 numbers that didn't equal each other, if I got 6 equals 4, that would be no solution. Okay, 2 things that equal each other. It could have been 0 equals 0, which is what I would have gotten if I had subtracted 14 from both sides there, so don't be thrown off by that. 0 does equal 0, that's why it's infinite. 2 things that equal each other. Which means infinite solutions will be, if you were to graph them, they would be the overlapping line kind. And if you get no solutions, that would be the parallel lines type if you were to graph them, all right? So I didn't put a whole graph in there, but you get the idea. We've already talked about that in the last video. So that's the answer, okay? Number 4. (2y minus x equals 5) and 3x plus 7y equals 24. Okay, so those go together. Clean up that 24. Do I have x alone or y alone? No, I don't. Not in either. So I'm going to go take this top one because I see that x is kind of all alone there. That's going to make it easier so I don't have to divide by the coefficient at the end. So I'm going to take that. I'm going to manipulate this equation to get x alone. There's a variety of ways you could do this. I'm going to just add x to both sides. And then I get 2y. Remember, you can't add 5 and x together. I can just go 5 plus x. Next, I want to get the x alone, so I'm going to subtract 5 from both sides, and I get x equals 2y minus 5. And that is an equation that I can now substitute into the other one. This will go in for x up here. So if I write this other equation with the blank parentheses, 3 blank parentheses plus 7y equals 24. In the blank parentheses goes my 2y minus 5. and now I'm going to solve it. Distributive property. Notice how I use parentheses there, very important. Get the wrong answer every time if you don't use parentheses. Anytime you're substituting in. Alright, 3 times 2y is 6y. 3 times 5 is 15, plus 7y equals 24. I can combine like terms. 6y plus 7y is 13y. Minus 15 equals 24. Add 15. I get 13y equals 39. Divide by 3, I'll get my first answer. Divide by 13, excuse me. Y equals 3. Alright, now I got to find out what x is. So I'm going to take one of the two original equations. I'm looking at the one being 2y minus x equals 5 being easier. Pick the easier of the two equations. 2 times, we said y is 3. So that's 6 minus x equals 5. You could do mental math on this one. 6 minus what is 5? X is 1. 6 minus 1 is 5. You could also just subtracted 6 and solved it. Alright, so those are my two answers. You could write those as coordinates. 1, 3. That's another way to write that. Either way, it's fine. You should check your answer. I already did it out. I'm going to take it as, you have to trust me, that's the correct one. Alright, number 4. Or is this 5? Sorry, this is 5. And my last problem. And it's a word problem. Sharon has some $1 bills and some $5 bills. She has 20 bills. And the value of the bills is $80. A. Write a system of equations for the problem. And B, how many $5 bills does she have? Okay, so that's the problem. Shrink it. Okay. So the equation. So if I have x can equal the $5 bills, y can equal the $1 bills. It's good to label your variables like that. That way, when you're done at the end, you can figure out which answer you got. So this has two equations. There's the easy one and a hard one. The easy one has to do with how many bills that she has, which in this case she has 20 bills, which means if I take the number of $5 bills and I add the number of $1 bills, that will equal 20. The harder of the two equations has to do with the value of the money. If I take, the amount of money that, $5 bills are worth $5. So what is it, $5 bills, and $1 bills are $1, and they're going to total $80. Now, you have to, I don't know how many $5 bills there are, and I don't know how many $1 bills there are. So it's 5 times x plus 1 times y equals $80. Does that make sense? If I had 2 $5 bills will be $10. That's where you're getting that equation. Those are my two equations. Now I'm going to solve them. I'm going to take my two equations down here and solve it like a system of equations. 5x plus 1y is the same as y. Okay, so I need to get x alone or y alone, which means I'm going to take that top equation, and if I subtract y from both sides, I'll get x alone. I get x equals 20 minus y, and that is a value that I can substitute into the other equation where the x is. Certainly not the only way you could have done this equation. You also could have plugged in gotten the y alone. So if I go like this, 5, big parentheses, plus y equals 80. Now in the parentheses goes my substitution, which is the 20 minus y. Now I'm going to solve it using the distributive property. 5 times 20 is 100. 5 times y is 5y equals 80. Negative 5y plus 1y is negative 4y. Next, I'm going to subtract 100 from both sides. 80 minus 100 is negative 20. Divide by negative 4. And I'll get my answer of y equals 5. Okay, so if y is 5, she had 20 bills altogether, which means 5 plus 15 is 20, or you could have taken that original equation, x plus y equals 20. And solved for x. Subtract 5, x equals 15. Okay, and then go back to your original equation. Now is why it's nice to have written down which one x is and which one y is. X is the number of $5 bills, and that's all they asked for, which means they want to know this one, 15 $5 bills. And that's the answer. You could always go plug it in, 15 times 5 is 75. $1 bills are 5 of them, so 75 plus 5 is $80, and that makes sense, which is what the problem originally talked about. All right, so that's all I got for today. Thank you for watching. I'll see you all soon.